Okay, here we go. Question 14. Function f of x, 3x minus 5 over 4. We're given the x number to put in is minus 7, so 3 lots of minus 7. Minus 5 over 4 is minus 26 over 4, which gives an answer of minus 6.5. Okay, so this notation, f inverse. Remember, when we ask for the inverse function, we need to set it up as changing the subject. So I lay it out as y equals 3x minus 5 over 4. I'm going to rearrange this so I end up with something that says equal x rather than equals y. So multiply the 4y equals 3x minus 5. Take the 5 across, 4y plus 5 equals 3x, and divide by 3. So I've rearranged it to find out what my input is. In function language, if y is my output. So we're going back from our outputs to our inputs. Consequently, when I write this in function notation as the inverse function, I'm putting in a starting value, so the y needs swapping over with an x. So final inverse function is 4x plus 5 divided by 3. What have we got here? Part C. Another function, this time it's g, so the g function is the square root of 19 minus x. Now fg3 means that I do the g function first and then I do the f function. So I'm finding out what happens when I put a 3 into g, so you get the square root of 16, which is 4, and it's that 4 that then needs to go into the f function. So 3 lots of 4 minus 5 divided by 4 gives a fraction 7 over 4, which you can write as a decimal 1.75 as an answer. Okay, which cannot be excluded in the domain. So what inputs can we not have in this g function just here? Well, we wouldn't be able to do the square root of any negative numbers. So when 19 minus x is negative, we wouldn't be able to do it. For it to be negative, 19 minus x would need to be less than 0. Just take the x to the other side and you find that if x is bigger than 19, then you wouldn't be able to do that square root. So final answer, if x is bigger than 19, they are your excluded values from the domain.